Hello, and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This is the 50th video I have made based on individual articles in the book, and it is the third and final video in this playlist on samples. It is called Sample Size Part 2 for Measurements or Continuous Data. See statisticsfromatoz.com/videos for the latest status of my videos, completed and planned. As usual in the book and in these videos, we'll start by going quickly through a list of keys to understanding, or KTUs. This will give you the overall picture of the concept on a single page. And then we'll go into detailed explanations of each of the keys. For this video, there are 5 keys. The first key to understanding tells us that measurement data, also known as continuous data, contains more information than count data, so smaller sample sizes can achieve good accuracy. KTU number 2 says, if your focus is on avoiding an alpha error, that is, avoiding a false positive, you can calculate minimum sample size for a test of the mean using these 3 things: alpha, the selected level of significance; sigma, the standard deviation of the population or process, or an estimate of that standard deviation; and MOE, the desired margin of error. Key number 3 says, all other things being equal, an increase in sample size, n, reduces all types of sampling errors, including alpha and beta errors and the margin of error. Key to understanding number 4 says, a larger sample size enables smaller differences, that is, smaller effect sizes, to be detected. The 5th and final key to understanding says, statistical software or websites perform power and sample size calculations that can be used to determine the minimum sample size required for a given level of power or effect size. And here on one page are all 5 keys to understanding the concepts in this sample size part 2 video. You may wish to pause the video at this point and read them all together. Okay, now let's take a closer look at each key to understanding. First, KTU number 1 says, measurement data, also known as continuous data, contains more information than count data, so smaller sample sizes can achieve good accuracy. The Part 1 video addressed the minimum sample size for count data, which is also known as discrete data. Count data are non-negative integers like 0, 1, 2, 3, and so on. Proportion is the statistic commonly used with count data. Measurement data, which is also known as continuous data, are collected by measuring things, measuring widths, for example, not by counting. Measurement data will often have decimal points. For example, these measurements in centimeters were collected on the diameters of 10 holes drilled in a manufacturing operation. 1.9, 2.1, 2.0, 2.1, 2.1, 2.0, 2.2, 2.0, 2.0, and 2.2 centimeters. The quality specification limits state that the hole must be 2.0 centimeters plus or minus 0.1 centimeter, otherwise it's a defect. Now, if you can't capture sample data as measurements, don't convert it to count data. Information is lost in converting measurement to count data. In the sample of 10 measurements above, 2 of the measurements were outside the specification limits. So we might think about recording a count of 2 as the number of defective items in a sample size of n equals 10. What we would then know about the sample would be summarized in one statistic. The proportion of defects equals 2 divided by 10 equals 0.2. On the other hand, treating the same data as measurement data, we can say a lot more. We can say that the mean is 2.06, the mode is 2.0, and the standard deviation is 0.097. So usually what we don't want to do is convert this measurement data to count data. The measurement data contains more information, and this information can be used to give us better accuracy with less data. And/or we could use a smaller sample size to get good accuracy. In inferential statistics, such as t-tests, regression, and ANOVA, there is a risk of alpha error, which is another name for a false positive. And there is also a risk of a beta error, which is a false negative. Most commonly, the tester tries to minimize the alpha error. If that's our focus, KTU number 2 tells us that we can calculate the minimum sample size for a test of the mean using alpha, the selected level of significance, sigma, the standard deviation of the population or process, or an estimate of sigma, and MOE, the desired margin of error. We can do this by algebraically manipulating a formula which has these three variables. For example, margin of error, MOE, equals the standard deviation times the critical value divided by the square root of the sample size. Sigma is the population or process standard deviation. Often we don't know it, so we must use an alternative, such as an estimate from previous studies, or an industry standard, or a sample's standard deviation. Alpha is used to determine the critical value. For example, from a table or from software, we know that the critical value of the test statistic Z for a two-sided test with alpha equals 5% is Z sub alpha over 2 equals 1.96. A little algebraic manipulation gives us the sample size n equals sigma times the critical value squared divided by the margin of error squared. Now, minimizing false negative errors as well as false positive errors makes for more complicated sample power and sample size calculations, as well as discussed in key to understanding number 5. KTU number 3 says, all other things being equal, an increase in sample size, n, reduces all types of sampling errors, including alpha errors, beta errors, and the margin of error. As we discussed in the first video in this playlist, a sampling error is not a mistake. It is simply the reduction in accuracy which we expect when we make an estimate based on a portion or a sample of the data in a population or process. There are several types of sampling error. Two types of sampling errors are described in terms of their probability. P is the probability of an alpha error, that is the probability of a false positive, and beta is the probability of a beta error, that is the probability of a false negative. The third type, the margin of error, MOE, is the width of an interval in the units of the data. It is half the width of a two-sided confidence interval. All three types of sampling error are reduced when the sample size is increased. KTU number 4 says, a larger sample size enables smaller differences to be detected. In manufacturing quality studies, for example, the specification limits which define the acceptable range of measured values can be quite narrow, so it is important to be able to detect small differences. That is, the effect size of the test is small. To detect small effect sizes, the power of the test must be high. Power is the probability of not making a beta error, which is a false negative. One way to increase power is to increase alpha, which is the acceptable threshold for the probability of an alpha error. But normally we don't want to do that. The only other way to increase power is to increase the sample size n. KTU number 5 says statistical software or websites perform power and sample size calculations that can be used to determine the minimum sample size required for a given level of power or effect size. We said earlier that if all you're interested in is avoiding alpha errors, then you can use some simple formulas for minimum sample size. But for some areas like medical research and process quality improvement, avoiding beta errors is very important. When we add the need to manage beta errors and effect sizes, the formulas for minimum sample size can get very complicated and are beyond the scope of this book and video. However, there are a number of commercial and free statistical software packages and websites that will do the calculation for you. Okay, that concludes our sample size part 2 video. See the videos page on my website, which is statisticsfromatozee.com/videos, for the latest status of videos completed and planned. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website statisticsfromatozee.com has a listing of available and planned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn more about those on the website. I'd recommend following my blog at statisticsfromatozee.com/blog. I've got some things there that hopefully you'll find interesting, like statistics tips, as well as posts showing that you are not alone if you're confused by statistics. I'll also be posting on the Facebook page, Statistics from A to Z, and on Twitter is @StatsA to Z.